Hello everybody, and welcome to the lesson on radian measure and arc length. One of the reasons that radian measure makes more sense in some instances than measuring an angle in degrees is because if you know, for instance, the length of the radius and the length of the arc that the angle has intercepted, you can find out the measure of the angle in radians. Or if you know the measure of the angle and you know the length of the radius, you can figure out the length of the arc that the angle has intercepted. Or if you know the length of the arc and the measure of the angle in radians, you can figure out the length of the radius. So if the angle is measured in degrees, it doesn't make it as easy to do that. So the basic formula, well, the first thing we need to look at is the angle measured in radians is denoted by the Greek letter theta, which is like a zero with a line through it. S is the length of your arc, and R is the radius. So the basic formula is the length of the arc is equal to the measure of the angle in radians times the length of the radius. So if you know the arc and the angle measure, you're trying to find the radius, you manipulate the equation to get that. Or if you know the arc and the radius, you're trying to find the measure of the angle, you manipulate the equation to get that. Now the classwork, you've got to read it carefully to decide, are you using S is equal to theta R, or R is equal to S over theta, or theta is equal to S over R, all right? So the examples I have here are all going to be using theta is equal to S over R, okay? So in each diagram below, particular radius, particular arc length, what's the radian measure of the angle, okay? So theta is equal to S over R. So theta is equal to 6 over 4. We have to reduce the fraction, which is 3 over 2, or 1.5 radians. Okay. Next one, again, theta is equal to S over R. So theta is equal to 8 pi over 12. So theta is equal to 2 pi over 3 radians. Okay. You got to remember, as we went through yesterday, it's going to be a fraction. Pi's in the numerator. Okay. It's not going to be 2/3 pi. It's 2 pi over 3. All right. You have to remember that. This one is equal to, sorry. Theta is equal to S over R. I don't know why I wrote a capital R. Okay, so theta is equal to 5 pi over 10, which is pi over 2 radians. All right, you have to make sure you're reducing your fractions. And the last one, theta is equal to S over R. So theta is 34, radius is 8. And you can reduce that to 17 over 4, or 4.25 radians. Okay, so this is the lesson for radian measure and arc length. This lesson was brought directly to you from my dining room table.